Hello, good afternoon, everyone. Thank you for joining us. My name is Tatiana Block. I am a senior project manager at the New Energy Coalition, and it's a pleasure to have you with us today for our webinar on confidence in underground hydrogen storage in Zuidwending in Enel, in the Netherlands. This webinar is part of the communication and dissemination activities of the HEAVENN project, which I have the privilege to lead in terms of work package activities. HEAVENN is one of Euro's flagship hydrogen valleys initiatives. And our main goal in HEAVENN is to build a hydrogen economy in the northern Netherlands. And the idea is to drive a broader socio-economic transformation in the region. One of our main goals as well is to demonstrate the implementation of hydrogen value chain, including hydrogen supply and demand and the infrastructure required to connect both sides. So in the Netherlands, we have already a capacity to store hydrogen in the, to store hydrogen in the underground. And we have a long experience also, decades of experience actually, of successful operation of storing underground natural gas in the subsurface. And this underground natural gas storage is currently used to balance the seasonal variations of supply and demand of natural gas and to guarantee the security of energy supply in the country and Europe. So we think that low carbon hydrogen can be used for the same applications. And underground hydrogen storage is how we call this technology or this technique. Is a reason, is a very important element to achieve that socio-economic transformation that we want in the region. So it is a critical enabler for the region and for the energy transition in the region, and it could also, one of the role of hydrogen storage, underground hydrogen storage, is to also provide a large scale, long duration hydrogen storage capacity and to balance the variability of renewable energy and of course to ensure security of supply. It will also support the development of of the use of hydrogen in the industrial sector, mobility, and cross-border hydrogen markets. So if for us, for the project, and I think in the realm of energy transition, it is clear that the underground hydrogen storage can play a role in building that resilient and competitive regional hydrogen ecosystem that we want to achieve in the north of the Netherlands. However, the operations that are related to the storage of hydrogen in the underground must be safe and in order to protect the environment and the communities in our surroundings. So this is why this is an important objective within the HEAVENN project. The HEAVENN project is made, as I mentioned, we want to have developed to demonstrate the whole hydrogen supply chain and the operability of it. And that's why we included an activity related to demonstrate the safe injection of hydrogen in the underground, specifically in salt caverns in the location of Zuidwending. And these activities were performed by one of our partners in the consortium of the Project HEAVENN, which is Gasunie. And they demonstrated the technical feasibility of this injection, the hydrogen injection in the salt caverns, and the safety aspects of it. However, we realize, or based on the learning and experience of Gasunie in this activity, we have gathered all these learnings and prepared this webinar for you to bring their experience and knowledge, because what we want to send, the main message to send in this webinar, is that in order to have a safe operation and a good understanding of the community and feeling actually about these operations from the community, is to approach this um, engagement with the community from several angles. So only the technical demonstration is one of the aspects that is important to for the community to understand that it can be done safely, but also we need to approach building this confidence in other, taking into account other parameters or other aspects of this implementation. And this is why Eddy has been invited to explain even better what this is all about, and he will elaborate more on during his presentation about how building confidence in hydrogen storage based on the experience on Zuidwending and the project of Zuidwending. So having said that, I would like to take you to the what is the activities of the day, and we have this. Sorry, I lost the screen where I can. Yeah, I see you now. We are going to talk today about indeed the public engagement experience from Eddy. And then we are going to have Q&A section for all the questions that you may have, and all the questions that Alba, our other guest from the University of Groningen, will have prepared for us and for you. And also at the end, we can have a more dynamic conversation on what are the experience and learnings from Gasunie shared by Eddy. So let me also remind you that this webinar is being recorded, so it will remain in the repository of the HEAVENN project. And please share the voice with your colleagues if they could not see the webinar today, join us today. It will be made available for for future audience. So now I would like to give the floor first to Eddy and Alba to introduce themselves, and later Eddy can kick off formally the presentation on the material that he has prepared for us today. Thank you both for being here, and I leave the floor to Alba first, and then Eddy can take over.
Thank you, Tatiana, and thank you everyone for being here today with us. And thank you, Eddy, as well, for having accepted this kind invitation by Tatiana and the HEAVENN team. From my side, I am Alba Forns. I'm a third-year PhD candidate at the University of Groningen, and I am based at the Faculty of Law. And my research specifically focuses on the regulation of the hydrogen economy, with special regard to the citizen empowerment of our neighbors, so to say, or of our local residents. And also, I work a lot in just transition. So today, for me, it's a pleasure to be here, and I look forward to Eddy's presentation and to the Q&A section later. Thank you, Tatiana.
Eddy, the floor is yours.
Yeah, thank you. So my name is Eddy Kuperus. I work in Gasunie as a business development manager for hydrogen storage. And my presentation will be about that topic and the experience that we have over the last years in this topic. So shall I see if I can share my screen?
Please.
Here we go. So I've titled my presentation "Confidence in Underground Hydrogen Storage." There's a whole lot of slides, lots of topics. So let's start. And pretty sure that you know the company Gasunie, but I thought let me start with this slide, and it is about what is Gasunie. And Gasunie is not only a pipeline company, and it's also not only about natural gas, but
Excuse me,
actually,
Eddy, I think we cannot see your slides.
why not?
I don't know.
Let's try again.
Yeah.
Ding, 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 ding. Let's try again.
Yes,
So,
we have them.
great. So I already
Fantastic.
started with this slide. So I hope you can see it. It's about Gasunie. What is Gasunie? And what you can see here is the pipeline network for natural gas of Gasunie in the Netherlands, but also in Germany. It stretches out to the very east of Germany, and of course covering the Netherlands and to the UK. Also, Gasunie is working on a hydrogen transport network called the HI network. And we are involved in developing a hydrogen transport network in Germany, which is called the caverns. But that's not only that. We are also involved in import stations for natural gas, which are in operation in Delfzijl in Rotterdam. But we are also working on hydrogen import projects. One of them is the ACE terminal in Rotterdam. We are active in storage, in natural gas storage in Zuidwending in the energy stock project. And we are developing the high stock project, which is a hydrogen storage project in Netherlands, and H2Cast project, which is in Germany. And there is a third hydrogen storage project in development, and that is called the Speicher project in Germany. And then we are also developing CCS, of which the Portos project is under construction. But there is also other projects like Aramis and CO2 Next, and of course the Delta Rhine corridor, which is an important transport pipeline system to Germany to transport hydrogen and CO2. So lots of activities. And then I forget to mention that we are also involved in a heat network. So it's a quite spread activity and lots of focus on the future energy system. This slide is about why would we store hydrogen? Well, one can say that hydrogen storage is indispensable for a well-functioning hydrogen system. What does that mean? To balance the imbalance between the supply and demand, you need storage, and that storage can be of short term, it can be a longer term, it can even be a strategic storage, and that all can be done in the deep underground in either salt caverns, or it might even be possible in depleted gas fields. In general, one can say the bigger the volume, the more obvious it becomes to store hydrogen in the depleted gas fields. And if you want to have a fast cyclic storage, so let's say variations balancing in hours or days, then typically you will use a cavern. To put storage a little bit in perspective, I've added this slide. On the left-hand side, we present the storage means for electrons. So that goes from batteries that you can install at your house, which are typically 10 kilowatt hours. You can have storage in your electric car, well, typically, let's say between 50 and 100 kilowatts. Then you can have a mega battery. There is mega batteries being developed in the Netherlands. And then you talk about, let's say 2500 megawatts. That's already a big one. When we talk about storage in one salt cavern of hydrogen, we talk about gigawatts. So the storage in one salt cavern is approximately 100 times as big as the storage of electricity in the biggest mega battery we can think of. So there's a huge scale difference. And when we go to the other side of this slide, you can put roughly 30 kilowatt hours of energy in a gas bottle. In a tube trailer, it's approximately 30 megawatts. In a terminal, it's probably 10 gigawatts. And when you go to the storage in a cavern again, it's a factor 25 bigger. And then when you go to a gas field, it's even a factor 40, 50 bigger. And you can go up to, let's say, 10 terawatt hours of storage. So there's a huge variety in storage capacities. And we believe that the energy system of the future will require all storage means, because every way of storing energy serves a different purpose. So it will not be one type of storage in the future, but it will be a combination of different kinds of storages. And I already mentioned it. At this very moment, we see in the Netherlands two types of hydrogen storage in the deep underground. That is either in salt caverns or it's storage in depleted gas fields. And when we look at the technical readiness level, we see that the development of storing hydrogen in caverns is much further. It's much more developed than when you look at hydrogen storage in depleted gas fields. And several pilots have shown that storing hydrogen in caverns is technically feasible. And there is one or two pilot projects for storing hydrogen in depleted gas fields initiated as well. So we will get there. So then one can say we are storing natural gas already for decades. What makes it so different to store hydrogen? Well, basically, it's the same. However, the hydrogen is not behaving exactly the same as natural gas. First of all, it takes much less energy to ignite hydrogen. So it has much wider explosion limits. And that means that it requires even more awareness for risk factors for the operations and for the design of your plants. Another typical difference is the fact that hydrogen is much lighter compared to natural gas, so it can move much faster. And the molecule of hydrogen is slightly smaller than a methane molecule. It's roughly 85% of the size of a methane molecule. So it is not true if you think that a hydrogen molecule is much smaller than methane. It's slightly smaller. The atom, however, is much smaller. And because of this lighter molecule and slightly smaller molecule, we need to investigate if materials and technologies and component designs to suit that physical difference. And also, there are no or hardly any norms and standards in the underground gas storage business that are applicable to hydrogen. So that means we have to review all the standards and adapt standards or define new standards for hydrogen storage. And last but definitely not the least, hydrogen is highly reactive. And that means that hydrogen can easily react with the surroundings, which can result in the formation of impurities, and it can also lead to the loss of stored hydrogen because of these reactions. Well, all those reasons, all these effects are reasons to do pilots to find what exactly happens if we store hydrogen. In 2018, Gasunie started with a pilot project, and we call it the A8 demonstration project. And our idea was to use our knowledge for underground gas storage and see if we can apply that knowledge in storing hydrogen. And let's try to learn from that. So we had 4 main topics to learn, and that was the cavern and the well integrity. So can we confirm that we can store hydrogen in a small cavern, and is the integrity, does it remain intact? We wanted to test the components which have been designed for underground gas storage, if you can apply them in hydrogen. We had focus on the operational procedures. So how does that work to work with hydrogen? Do our standard procedures for natural gas fit in hydrogen? And the last topic was, does the hydrogen react with the surroundings? So is there a chemical reaction, geochemical reaction with the salt, for instance, and hydrogen? And another question, would we get bacterial reaction? So would there be microbes that grow and eat the hydrogen and make a pollution, for instance, H2S, which can be quite detrimental for materials and also for people if it leaks out. So we have set a whole program that has been executed. It was finished in 21, and we have issued a few papers on our findings. But in general, one can say that we did not find any reason why hydrogen cannot be stored similar to natural gas storage. Another pilot project is at this very moment, a pilot project. It's in Delfzijl. It's called the H2Gas project. There we have put 90 tons of hydrogen in a cavern. And we have 2 caverns, and we can cycle hydrogen from one cavern to the other. Gasunie is at this very moment building a surface facility to make it possible to let the hydrogen flow from one cavern into the other. And that makes that we can make many cycles. And in the surface facility, we have built different technologies to remove impurities. Impurities as water vapor, hydrocarbon remaining in the cavern and polluting the hydrogen. And also, how can we remove sulfur if it is in the hydrogen stream? So this facility is being built, and we expect that it will be ready by, let's say, the first quarter of next year. and then we can use the facility to do our tests. The design of this plant is unique in this size, so it's really a next step for learning. What was already mentioned, we are as Gasunie also working on the HyStock project, and the HyStock project is a full-scale 1 terawatt-hour hydrogen storage facility, which will be built in Zuidwending, close to the existing natural gas storage from Energy Stock. In this slide, there is a AI-generated picture. In the top, you can see the existing gas storage facility, and in the forefront, you see the prognosed hydrogen storage facility. And what is interesting to see is that the size of the facility for hydrogen storage is bigger because you need bigger space because of the fact that hydrogen is much lighter than natural gas. Our project aims for the first storage by 2032, and then during the years there will be caverns added to the project. At this moment we are working on the detailed engineering. We are in the middle of the permitting process and in the process of funding and the business case. H2Cast project I already mentioned. Then we are also working on a scale hydrogen storage in Germany. It's pretty similar to the HyStock project. It's located in Eddelzijl, and in Eddelzijl there is a salt dome where already 99 caverns are in operations. No, that's not true. 75 are in operations, and there is 24 remaining spots to put new caverns, and a few of those caverns are prognosed to be used in this Speicher project for hydrogen storage. This project is in the concept engineering phase. We are working on the permitting process, and we expect to have the first storage capacity available by 35 or in the period 2040. And for the rest, the technology is pretty similar to what we apply in HyStock, and of course, therefore, we try to have as much synergy as we can. My slides so far were all about technique, and we as Gasunie, we have confidence that we can safely store hydrogen in the deep underground. We have done the pilots, so for us that is under control. However, if you want to be successful in hydrogen and in hydrogen storage, you have to be successful in the 4 quadrants which I have shown here on this slide. So it's not only that you need a technical sound project, so you have to have confidence in your technology, but you also have to have a market, because without a market, there is no need for storage. You need a system, so a pipeline system which is reliable, and without a system and without a proper integration of the storage in the system won't work. And last but definitely not least, you need societal acceptance. So as a society, we need to have the willingness to change and to change to the new energy system. That means societal acceptance also goes with safety and perceived safety. Let me phrase it like that. And of course, we as an industry, we have to minimize the nuisance to the max. Like I mentioned, the pilots as we have performed so far, they were needed to get a successful project, but we need to be successful with political support on various levels. We need societal support, and also important, we need one way or the other support schemes to support the market and to get the economics right. That means that we need production of hydrogen, we need the consumption of the hydrogen, then we get a market, and then we can get the system working. So those are really important. When we look at the storage demand, the prognosis show, and these pictures are graphs. The left one is the prognosis in the Netherlands, how much storage is required. On the right-hand side, you see the prognosis for Germany. And I don't want to go through the numbers, but what you can see from these two pictures is that there's a huge uncertainty in how much storage is required. There is a tendency that there is some postponement in the ramp up of the hydrogen market, but all the numbers show that we need a huge amount of hydrogen storage if we want to make the system work. And that means that projects are needed to get the things going. I want to remind you that the project in Zuidwending and in Germany, the project we work on, have roughly 1 terawatt hour in storage. And as you can see here, for the Netherlands only in 2050, the prognosis is that there would be at least 11 or 12 terawatt hours required for storage. So there's still quite a gap to fill. This slide is about an interesting site which I invite you to have a look. It's the Waterstofkaart Nederland. And in this map, you can see all the projects in hydrogen, in consumption or in production, prognosed. You can see in this map where these projects are and what the status is of these projects. It's really an interesting site. And on the site, and from that you can see that there is lots of projects under development, and hopefully these projects will be FID'd, so there will be final investment decisions to proceed and also to realize these projects. Another interesting site is the site of the high network services and the Kernets site. Here you can see what is going on in the Netherlands and in Germany with respect to developing the transport network. Only in Germany, there is something like 9,000 kilometers of hydrogen transport network prognosed. So that's a huge task to have that, to realize that one. And there I want to stop. So if you have any question, raise them now or raise them later by sending an email.
Thank you, Eddy, for the interesting presentation and the view, not only in the Netherlands, actually, but also what Gasunie is doing in Germany. I think that was a great addition to the content. And yeah, I do have a comment on the slide that you presented with your dimensions, the 4 dimensions that you have identified on the, yeah, for a successful hydrogen storage implementation. I do agree that we need the activity, not only this activity in the hydrogen value. If we look at things from the hydrogen value chain perspective, hydrogen storage is one of them. But I think in general to have in that successful implementation of the value chain and its elements, indeed we need political support in different levels, social support and support schemes. And this support actually is embedded in the hydrogen valley concept. And that's why it's so important to develop this project not only in the Netherlands as we are demonstrating now, but also across Europe, so we can have we can achieve all the goals that we have set for this creation of hydrogen economy. So for instance, in HEAVENN specifically, we have the local support of the province of Drenthe and Groningen during the creation of the project, and also during the implementation. They have been supportive in being first providing support schemes financially, but also they have worked together with the partners in developing, assuring that if we have an issue from the regulation point of view, or there is a way that they can influence the ecosystem for us to have a successful implementation, they will work along with us. Also, as you mentioned, the political support in different levels, that's an example, a provincial level. If you will zoom in at a regional level, a very local level, we have the cities of Hoogeveen, the municipalities actually of Hoogeveen and Groningen being active actors of the project by implementing their own activities, like the use of hydrogen in Hoogeveen. We had a seminar before that, before this one, on that topic, and also how the public engagement play an important role on their success. And for the in the case of the Groningen municipality, they are demonstrating the use of trucks, the use of hydrogen to power trucks that are used to clean the city and to collect garbage. And European level, of course, the concept of Hydrogen Valley was created by the European Commission and has been implemented by the Clean Hydrogen Partnership since 2019. As again, HEAVENN was the first and is the pioneering project, Hydrogen Valley project in Europe, but also so far the Clean Hydrogen Partnership have helped contributed to develop the 20 more hydrogen valleys, and there are more to come the next years. So I think we have the political and the financial schemes there to help us demonstrate these activities. However, there are regulations that need to be put in place to enable all this framework that they have created. And that's what we have the same discussion before with other partners and in the Hoogeveen webinar, that I invite the audience, by the way, to look at. If you miss it, the recording is also available in the website of HEAVENN. But the regulations and policies to keep on enabling these wishes and thoughts and activities that we're taking, that are taking already place to continue the development of the Hydrogen Valley. So the Valley and the hydrogen economy. I would like to, we have a question from the audience, many questions, and the first one is Alexander. We can start the Q&A session with that question specifically. And his question is about what will be the quality you need and get out of the cavern. So I guess to inject and to extract hydrogen from the caverns. What impurities are allowed and what is not allowed?
Well,
A bit technical question.
easy answer, yes. No, it is to be defined. There is no, so our goal would be to have one standard in Europe. So you have one European market and you can flow your hydrogen from north to south and east to west. At this very moment, there is still quite some discussions on the purity level of the hydrogen in the system. There is countries that say we should strive for the highest hydrogen quality, so that means 99.5 purity. There is also countries that say, well, we can also go for a lower quality. From a storage perspective, and then in particular, if you reuse existing caverns that have been used for gas storage, or when you use depleted gas fields, then from that perspective, you would like to have a hydrogen purity level which is not too high. So that means we think of a purity level of 98%. That means that 2% impurities could be in the hydrogen. And then, of course, the next question is which impurities are allowed and which not. And again, that is a discussion which is ongoing. There is an organization called Easy Gas, and they are working on a European standard for hydrogen quality. When we talk about the H2CAS project, where we do the purity, there we focus on removing liquid, so water. We focus on removing hydrocarbons because the project is focused on reusing existing caverns, where you have a certain amount of hydrocarbons left in the cavern, which come back with the hydrogen.
Right. Thank you so much. Alba, would you like to share your questions with us? We are curious.
Yes, I think we can. I've seen that our attendants are quite active, so I think maybe it's better to address their questions, and then I can finalize if we have the time with some questions that we had already addressed with Eddy in our previous preparation meeting. What we can see is that Alexander, for example, he asked a more technical question based on the confidence quadrants that Eddy was sharing before. But now we also have a question from Claudio that is more related to the societal acceptance quadrant. And he's asking us, what is the social acceptance so far in the area where we have high stock at the moment? And what do the local representatives say in relation to this project?
Well, I think in general it's a relative positive for the people living around the Zuidwending area. There's a relative positive feedback on hydrogen storage, and also in Germany there is that's actually a really positive vibe. Myself, I work more in Germany than in Zuidwending, and what we see in Germany is that there is a local benefit of economic activities in the area that makes that people are really pushing us to do these activities. In the Netherlands, the system is a little bit different, so that is a little bit different. But still, there is, I would say, a overall a pretty good acceptance of the hydrogen storage in the area.
Perfect. It's also interesting to see, right, that in the province of Groningen, we've had some opposition to natural gas projects, and now the social acceptance of hydrogen, it doesn't feel for the citizens as risky, right? It's good to see that. Then we have another question again from Alexander. Thank you. Who's asking us which customers for hydrogens and amounts are in the Netherlands?
I can't give an answer to that one.
Mm-hmm.
Yeah, well, I can tell Alexander about what are we doing in HEAVENN in terms of market development. So as I mentioned, we have in HEAVENN we cover both the supply and the demand creating the supply and the demand of green hydrogen. And what we have included in the scope of HEAVENN is to demonstrate the applications of hydrogen or green hydrogen in our particular case in different sectors. So we are looking at the industrial sector application as feedstock in the area of Delfzijl, where there are chemical processes that currently use gray hydrogen that were not considered green hydrogen fully, at least before the beginning of the project. So we are demonstrating the use of hydrogen as a feedstock in chemical process in that region, and also in Emmen, in the eastern part of the country, we are demonstrating the use of hydrogen to be used as energy vector to generate heat for industrial processes as well. So that's in terms of industry. And in terms of other applications, we have the use of hydrogen in houses. That's the case in Hoogeveen. We are also demonstrating the use of hydrogen in cities operations. I mentioned the example already. And also in green mobility. We have a cluster developed or devoted to demonstrate the use of hydrogen in the mobility sector for trucks and taxis and vehicles. So that's what we are demonstrating in HEAVENN. And one of the output of HEAVENN will actually is already available in the website. It's a study on the market and future markets and demands for these applications. And we also have a study done available in the website as well to see what are the opportunities of the use of liquid hydrogen in the Netherlands, in the region. So that's beyond the demonstration. That study refers to activities or studies that have been done beyond the demonstration of HEAVENN and is forward-looking. In the future, HEAVENN will also create a deliverable on what is the roadmap for the green hydrogen roadmap for the region based on our experience. So there will be more about forecasts and on market development and how the region will achieve all these goals that we have set in HEAVENN for the future of the development of the economy, the green economy in the Netherlands.
Thank you, Tatiana. I hope that with both Eddy's and Tatiana's answers, our attendants are getting the input that they were expecting. Please keep on asking questions if you want, but in the meantime, I have prepared some questions that we can go through. One of the things that I was wondering, Eddy, is given the fact that you have two different ongoing projects, one in the Netherlands or several in the Netherlands and Germany, do you see some sort of different challenges in the authorization procedures, for example, of these projects? Like which of the two EU member states do you feel like simplifies a bit more the authorization of these projects, or if there are some regulatory challenges in both cases that differ from one country to the other?
So Germany and Netherlands, they are look the same. Of course, they are not the same.
Mm-hmm.
I think in Germany, the mining authorities might have a little bit a different view compared to the mining authorities in the Netherlands. And when we started with the developments, I think the Netherlands, they were really front runners for the hydrogen economy. I think that is now slowly changing, and we see that the interest of the German politicians becomes a little bit more compared to what happens in the Netherlands. So it looks like slowly they are catching up and maybe have overtaken the situation of the hydrogen development and the willingness to invest compared to what is at this moment happening in the Netherlands. And of course, the projects like HEAVENN, they are really important in getting things started. But if we really want to get started with a new energy system, it has to step up. It has to become much bigger. And you have to think about electricity plants that are running on hydrogen, or big industrial complexes which are completely switching to hydrogen. Only then we can make it happen. So that means, yes, we have to start with these projects like HEAVENN, and then build on from there to conquer Netherlands and Germany and the rest of Europe with the hydrogen. And that's still quite a step to make.
Yeah, that is an important point indeed, because we are focusing, well, in our webinar, of course, the experience in Zuidwending, etc. That's the starting point, but indeed, in order to have that longer term vision, we have to have a share long-term vision, and that's what is happening at a European level, that we need to develop also the infrastructure that is not on that is regional, but also will be interconnected across the continent, inland, and to have this exchange of hydrogen from different point of production to supply, and different points of demand. And also we need to think about, okay, what is the infrastructure that we need in ports, for instance, to allow to allow the import and export of hydrogen when we think in a global context.
Mm-hmm. Thank you once again, both, for your insights. And now I would like to go back to one of the questions we discussed in our preliminary or preparatory meeting, which was very interesting to me because it was related to the supply chain and the materials. I remember we discussed quite a lot on the materials and the suppliers, and also the improvement of certain skills of workers of certain suppliers. Like, which would be the challenges that you would highlight in the case of hydrogen storage?
So when we started with the A8 demonstration project, there was no supplier of hydrogen suitable equipment, or hardly any supplier. So we really had to motivate industrial suppliers to supply us materials. What we see now is that the market picks up and more material suppliers step in. And that is in line with the number of pilot projects which are being set up and initiated. So that's really good. These pilot projects will also help us to train people and to get experience working with the hydrogen. Because, like mentioned, hydrogen looks pretty much the same as methane, but it is not the same. So you really have to train people and make sure that the operations is safe. So I think we need all people to get interested and start doing trainings, and that means people that is now working in the industry, but also for new people, young people, students, on all levels. So from people that work in the field to people that develop technologies and procedures. We need we need everybody to make this hydrogen economy a success.
Perfect, Eddie. I think we are getting close to our um, end time. So
Yeah, we
my
have
last
5 minutes
question,
left. Sorry.
yes. So my final question would be that one that really gives the reason behind preparing this webinar, right? Which would be which are the lessons learned, the key takeaways that you would bring to our audience today when it comes to the Hive project?
Well, I think a an important takeaway is that from a technical perspective, we are able to store safely hydrogen. But we need those other three quadrants as well to make it a success.
Mhm.
And that is something that is really important. And I think from many pilots, they focus on the technique and the technology, but we have to take the other steps as well.
Yeah,
And I think the Heaven project helps in that. But it's really an important message that we keep on pushing on those other quadrants, the non-technical quadrants as well, to make it a success.
perfect. That would be all from my Q&A section. Now I pass the floor back to Tatiana to give the closing remarks. Thank you, Eddie.
Thank you.
Yes. Thank you so much, both Eddie and Alba. It's been a great session today, very interactive, and thank you to the audience for being participating during this session with their questions. I would like to remind you that because we're recording the webinar, it will be posted later on in the website, and also, yes, in Heaven, we are continuing we are going to continue next year with more webinars. I would like to invite you to keep to sign up to them. We will keep on posting announcements in our website and also in LinkedIn. So keep following us. And yeah, just to wrap up. Thank you both, and thank you to Kevin, our organizer behind the scenes. He is in charge of the marketing and communications activities for NEC, and he's supporting Heaven and our also own communications activities. So I appreciate that. And I think those are my farewell and see you soon words, and please keep tuned, and I wish you all very good holidays and safe holidays, and see you soon. Happy holidays.
Happy holidays. Thank you.
Bye bye. Thank you.